What if I told you that this week we saw the first unmistakable signs that quantum computing is no longer a technology on the horizon, but one that's arriving quietly and confidently into the present? Not as a curiosity, not as a lab demonstration, but as something reproducible, something verifiable, keyword, and also something that's astonishingly useful. I'm Jesse Welch, and in my spare time, I'm spearheading the reunification of Kansas and Arkansas. It was a very gloomy day today. I figured I would come outside and record out here. For some reason, I'm romantic like that. This is the Quantum Observer, a different kind of romance. The kind of romance where we explore the principles of quantum physics. We trace their evolution into quantum technologies, specifically quantum computing, and understand how they're going to reshape industries and markets and the systems that we all depend on. So this week of November 3rd, the future revealed itself in several very extraordinary ways. Why does this week matter? Well, this week was very remarkable, not because of a single breakthrough, and not necessarily because of multiple breakthroughs, although there were, but actually because multiple threads of quantum progress all converged at once. You see, for many years, quantum computing has always felt like this shimmering promise. I used to work in AI. I remember it was always almost there, right? One research paper away. Everybody says we're 20 years away from it being useful, because that's far enough that it's, you can make predictions. It's close enough that it feels like you're going to get to see it before you die. However, this week we're starting to see something really different. We're starting to see algorithms that deliver verifiable quantum advantage. We're starting to see hardware that has unprecedented fidelity. We're seeing qubits living longer than we've ever measured before. And we're seeing real industrial systems that are finally showing actual massive real-world speed-ups, which translates to money. So it's like the fog is beginning to be lifted, and the first outlines of a new computational landscape are coming together. So in science, progress usually doesn't happen in dramatic leaps. Instead, it's a series of small, careful steps. We all know E equals mc squared, but few of us have seen, and even fewer understand, the long, many years of math computation that went into that, that put that all together. But every once in a while, the math lines up, everything comes together, you realize that you've crossed a boundary. And this week, quantum computing crossed one. There were some major quantum breakthroughs this week. Number one, Google achieved verifiable quantum advantage. Tiny little startup Google, they have a new processor. It's called the Willow processor, and it accomplished something that was profound. Quietly profound, but wild. It actually ran the quantum echoes algorithm 13,000 times faster than the world's best classical computer, supercomputer, the Frontier supercomputer, if I remember correctly. The crucial word here is verifiable. For the very first time, independent labs can now confirm the results of this. This isn't like a couple years ago, IBM and Google, I think it was, got in a spat of who actually achieved a breakthrough. This is different. It's not a claim anymore. This is a benchmark, and it's also not speed for speed's sake. The capability unlocks really practical applications like enhanced NMR stereoscopy for drug discovery, which is a big one. New simulation techniques for battery materials, really any kind of material discovery. We can also improve modeling of quantum many-body systems, which, if you really understand quantum, well, if you think you do, you don't, but quantum systems are like systems of systems of systems, but things are moving from theory into actual infrastructure. Also, Quantinum, they launched something called Helios. It's the most accurate quantum computer. Quantinum system represents a completely new type of machine. They had 98 high-fidelity qubits, 48 error-correcting logical qubits, and then gate fidelities exceeded 99.9%. It's a new hybrid programming environment that they put this on. It's called Guppy. It's actually built for enterprise use finally. It's not research hardware. It's proper industrial hardware. In fact, JP Morgan, who you may have heard of, and BMW are already using Helios for chemical simulations. They're using it for material discovery as well, and some advanced financial modeling, because of course, anytime we get some new technology, we're going to figure out a way to apply it to financial markets. But here's the thing. For years, the limiting factor wasn't imagination. It was error. Hence, quantum error correction is like its own field. Helios brings us closer to the point where quantum computers remain coherent long enough to do commercially meaningful work. This week also, Princeton, speaking of which, excellent transition into what Princeton did. They broke the qubit lifespan record. So Princeton engineers, they extended the lifetime of a superconducting qubit to over a millisecond. That seems modest, right? But this is a historic breakthrough. In quantum terms, a millisecond is like an eternity. In fact, in quantum systems, time doesn't even really exist. I'll probably do a video on that later, but what that means, basically, is we can do more operations, deeper circuits, and vastly improved error correction. And since these qubits are built from tantalum on silicon, they actually can be integrated directly into existing architectures, including, going back to what happened earlier this week, Google's Willow chip. So this is how these systems, quantum systems, start to scale. These breakthroughs are actually helping each other. They're not piggybacking. They're not leapfrogging. They're connecting like a jetpack. Not only by adding qubits, but we're not just adding them and increasing those numbers. We're helping them stay alive longer to compute. So not only do we add more, but they survive longer. This week also, D-Wave and BASF demonstrated industrial quantum advantage. And this is one of the most extraordinary results of the week. And it didn't come from a lab. This came from actual industry. So D-Wave and BASF, they used quantum optimization to reduce a production scheduling task from 10 hours to 5 seconds, which is like a 20,000 times speed up. And this happened in a real facility. It had real output. And they saved real money. Quantum is not just accelerating science anymore. It's actually accelerating industry. This was actually the most interesting thing of the week for me. We've all been hearing things about data centers. If you work in finance or if you anything, you're going to know. Digital Realty, NVIDIA, and OQC made the first quantum AI data center in New York. It came online, right? In this facility, quantum processors sit alongside AI supercomputers, classical high-performing clusters, and also ultra-low-temperature cryogenic infrastructures. This might be the architecture of the future. It's not quantum replacing classical systems. It's quantum woven in to integrated computational ecosystems. This is the first blueprint of what a quantum cloud computing ecosystem might look like. As we all know, classical computing went to the cloud. Everything gets sent to these data centers, lots of processing, and then it spits out to you, feels instant. Now we're doing this at a quantum level. How do these breakthroughs from this week actually interconnect with each other? While each one of these milestones is really impressive on their own, together they form a really coherent picture. And it's really exciting when you start to think about how these are going to be put into production. So Google proves that quantum algorithms can now outperform classical systems in verifiable, keyword, ways. Princeton extends the lifespan of qubits, which means deeper and more stable computations. And then Quantinum packages these advances into a machine that enterprises can actually use. Not only that, D-Wave shows that quantum advantage already exists in real industries, which delivers measurable ROI. And then OQC's quantum AI facility demonstrates how quantum is going to integrate into the broader computing landscape. These are not isolated breakthroughs. It's a step in the same direction. It's the direction of actual commercial quantum reality. What does all this mean for the future? You know, if we zoom out, as physicists love to do, I am not a physicist, by the way, but we see the shape of what's coming. We are moving towards a world where molecular simulation is going to run thousands of times faster. Manufacturing lines and logistics in general are going to self-optimize in real time. Financial systems are going to model uncertainty with quantum native tools, and then AI systems are going to draw on quantum enhanced compute. And we're going to explore far richer landscapes of possibility. See, quantum computing is not going to replace classical computing. It's going to expand what's computable. And this week, the first real foundations for building that expansion to actually use were laid. It's really exciting. If you guys found this at all useful or entertaining, please subscribe. If you hate me, also please subscribe. Every week I want to bring a little bit of clarity, some context, and maybe a little sense of wonder, and share some of my excitement with what's happening in this rapidly unfolding world of quantum technologies. And as always, I would love to hear your thoughts, especially what you think was the most significant breakthrough of this really fascinating week, or if there's anything that I missed. Let me know. If there's something that you think I should have talked about but I didn't, please put something in the comments. Until next time, the Quantum Observer, thank you for watching.